Hello friends, today we're talking about adding, subtracting, and comparing fractions with like denominators. And what do I even mean by like or same denominators? Well, if you remember, we've talked about how the upstairs or up top, the top part of the fraction, that's the numerator, and it represents the part, the segment, the piece, and the bottom represents the whole, the entire thing, or whatever we're looking at, and that is the denominator. Downstairs denominator, upstairs with a U, numerator, downstairs with a D, denominator. So when we have the same or like denominators, that means that the number downstairs is going to be the same. So let me give you some examples of like denominators. 1/4, 3/4, 2/4, 5/4. Now, what do you notice about 5/4? 5/4, the numerator is larger than the denominator, and we call that an improper fraction. We'll get into that a little bit later. Right now, we're just going to stick to understanding how fractions work when they have the same denominator and when we're adding, subtracting, and comparing them. And so we can talk about other fractions with like denominators. How about 2/12 and 1/12 and 3/12 and 1,262 twelfths? That is such a wild number, isn't it? Anyway, now we have talked about visual understandings and visual models with fractions. So let's start with an example because we're going to be adding, subtracting, and comparing fractions. If I have a pizza, and here it is divided in half, well, because I'm dealing with halves, I'm going to say that one piece, if I eat one piece of the pizza, let's pretend, then that's 1 out of 2 pieces, and it's perfectly fine to think of fractions that way. 1 out of 2 pieces, which is also known as 1/2. But if I eat another half, I'm gonna add another half. I'm so hungry. Let's pretend that I'm gonna eat this whole other half. And you know what, guys? Like, I have definitely been so hungry at times that I think there have been maybe 1 or 2 times in my life that I've eaten the whole entire pizza. Well, when I have one entire half plus another entire half, I have actually had 2 halves. And in this scenario, 2 halves is the same as 1 whole pizza. And we talked about that in our last class. This is, I'm talking about the students that I teach, that whenever the numerator is the same as the denominator, it is the same as 1 whole. Give you some more examples of that real quick. If I have 3/3, that equals 1 whole. If I have 15/15, that equals 1 whole. If I have 1,250 over 1,250, that also equals 1 whole. So, you catch my drift? That's what we're talking about here. So, going back to adding, subtracting, and comparing fractions. Here, what did you notice? I added the 1/2 plus the 1/2, and it gave me 2 halves. Now, visually, it's important that you understand that. There is, however, a little bit of a shortcut. And it's fun, especially when the denominators are the same. When you have 1/2 plus 1/2, you can basically, you keep the denominator the same. And then what you're going to do is you're going to add the numerators, 1 plus 1, and that's going to give me 2. So when you are adding fractions with the same denominator, all you need to do is keep the denominator the same and add the numerators. In other words, you keep the downstairs the same and then you add the upstairs. Let's do a few examples. 3/4 plus 1/4. We're going to keep the denominators the same, and then we're going to add, and if you need to do it this way to break it down slowly, 3 plus 1, we're going to add the numerators. It gives me 4 out of 4. Let's do another one. Let's do 6 eighths plus 1/8. What do? We're going to add these numerators up. 6 plus 1. I shouldn't have used yellow. I realize that's not the best color to use. It might be hard to see, but the idea is that you get the 7/8 there. If we're thinking about it on a number line, let's use the example above, maybe. We've got, did I do this right? 1, 2, 3, 4, 5, 6. I'm going to need 2 more lines here. 0, and my phone's going off. 0 and 1. Let me make sure I have the right number here. We want to have 8 parts. 1 part. Oops, 1 part. 2, 3, 4, 5, 6, 7, 8. Okay, they're not perfectly equal, but in the interest of making sure that you understand visually what addition looks like on a number line, I am just going to show you that if you have 6/8 plus 1/8, this is one way that you can also do it. You can count 1, 2, 3, 4, 5, 6. That's 6/8. Okay, that is not the best number line drawing, I realize. And we're going to add 1/8. So here we added 1/8. And now, you know what? I just realized I put this 1 in the wrong place. Put the 1 here. I hope that didn't confuse you, but now we have 7/8 here. So some people, they like to do the jumping method. And guess what? It works the same if you are subtracting. Let's say let's do a smaller number line. Let's do 0 and 1. Divide it maybe into 3 parts. Let's say I have, why did I put a 0 there? Let's say I have, now remember, the 1 here is equal to 3/3. Let's say the equation is 3/3 minus 1/3. Well, we know 3/3 is at this tick mark here. Let me mark it right there. We're going to jump back 1/3 because we know each of these segments here is equal to 1/3. And let's see what we have. Well, we've got 1/3 there plus another 1/3 there. We are actually at the 2/3 mark. And again, what do you notice? All you need to do is keep the denominator the same and subtract the numerators. 3 minus 1 is 2, so your answer is 2/3. So adding and subtracting with like denominators works exactly the same way. And guess what? It also works the same with comparing fractions. Let's say I have 3/5 and I have 1/5. Well, the numerator that is larger or greater than the other numerator is going to be the larger fraction. Another example of that would be, let's do 1/4 or 3/4. Which one is bigger? Well, here we see that 3 is bigger than 1. So 3/4 is in fact bigger than 1/4. And if you need a visual for that, let's bring over our pizzas. I must be hungry because I keep talking about pizza. Anyway, well, here we've got 1/4 and here we've got 3/4, and you can see that the 3/4 is definitely bigger than this small little 1/4 slice. And we're going to leave it at that today, friends, because you know what? This is something that I want you to really practice and understand well, because when you are able to work with fractions with like denominators or the same denominator, it makes you that much better at working with fractions in general and later on working with decimals. So really understanding this and building that strong foundation or base with fractions is going to really serve you well. Anyway, till next time, mathematicians.